All right, hey everybody. I'm going to go ahead and apologize for this video. Both my slate is dead, and then I can't find my pen for my tablet. So I'm going to have to use my fingers, and so the handwriting is not going to be great, but the learning is going to be amazing. So here we are. The real number system. This is a review because y'all learned the real number system in seventh grade, so this is a review. All of a sudden my mouse is working. My mouse hadn't been working all day. What a coincidence. All right, so real numbers are the set of rational and irrational numbers. Now look at that beautiful handwriting. Look at that R. Can't get no better than that. All right, set of rational and irrational numbers. So that means nothing if you don't know what a rational number is and if you don't know what an irrational number is. So let's talk about rational numbers. Rational numbers are numbers that can be written as a fraction. So can be written as a fraction. Those are rational numbers. Numbers that can be written as a fraction. And rational numbers are terminating. Terminating means numbers that end. Terminating or repeating decimals. Decimals. Yep, we're going to pretend like that said decimals. You go ahead and write that out. All right, terminating and repeating decimals. So here are some examples of rational numbers. 1/3. Goodness gracious, that one looks a mess. I do have to erase that. 1/3 is rational because it can be written as a fraction. Y'all, I hope y'all are listening because these things you have to learn because they're not going to be, the notes are not going to be in front of you when you're quizzed on this Friday. All right, 5.7 is rational because it terminates. It stops at 7. Terminates. The negative 0.9 repeating is rational because it repeats. Right? That bar means it repeats. The square root of 25 is rational because the square root of 25 is 5. It terminates. It stops at 5. -6 is rational because it stops at -6. -3.85 is rational because it stops at 5. So, rational numbers can be numbers that can be written as a fraction, or they are terminating or repeating decimals. All of the numbers that are under here will be rational. So we move on to integers. Integers are numbers. Go on, scroll down, buddy. Integers are rational numbers. You see this box, this outline box, rational numbers. Integers are rational numbers, whole numbers, and counting and natural numbers are all rational numbers because they're looped in the big box. I think some people get confused. You see this big box right here? Everything in this box going down. I'm not going to go down again. Those are rational numbers. So integers are rational numbers. But what are integers? Integers are whole. Next time I might type this. Numbers. Ooh, look at that beautiful handwriting. And their opposites. All right, so what does that mean? That means integers can be negative or positive whole numbers, which is going to be an oxymoron when we get to whole numbers when they're actually positive. So -5, -4, -3, -2, -1, 0, 1, 2, 3, and so on are all integers because they're whole, positive, and negative numbers. What can't integers be? Decimals. No decimals. Decimals means I have a piece of something. We're saying whole numbers and their opposite. So the whole number would be 3. The opposite of 3 would be -3. Whole number would be 1. Opposite of 1 would be -1. 0 is an integer because it's not a decimal. Okay? No decimals. If we can't have any decimals, that means we can't have any fractions that are not over 1 or don't simplify to 1. No fractions. No fractions. Look at this handwriting. It's beautiful. Tell you. It's a masterpiece. No fractions unless they reduce to a whole number. Like 25 over 5 is 5. Oh, that's an integer. But 25 over 7 does not reduce into an integer. All right, use my English skills. Moving on. Let's move on down. Move on down the road. Come on, man. Oh, that's not what I want. All right. Whole numbers. Hey, whole numbers are whole numbers. So these include 0. I have a whole lot of nothing. Y'all see that? 0, nothing. I have a whole lot of nothing. Whole lot of nothing. Yeah. All right. 0, 1, 2, 3, 4, and on and on and on. What don't we see in here, people? We see no negatives. Whole. I'm whole. I can't be negative. Even though I know the previous thing, I just said whole numbers and their opposites, so the opposites will be negative numbers, okay? So whole and their opposites. And means that something else is included. So no negatives. What else do we not see? No decimals or fractions. But again, all these numbers are what? Integers, because integers are numbers written as a fraction or terminating. All these numbers terminate. 0 terminates. It stops at 0. 1 terminates. 2 terminates. 3. So they are all integers, but these type of numbers are integers and whole numbers, and they are also, watch the box, they're also integers. Whole numbers are integers. You see that? It's located in the integer. Because some of y'all blind. Some of y'all may be colorblind. Don't you see the color? I'm sorry about that. I'm not picking on you, but this is, I guess somebody said fuchsia or some kind of pink or something. Magenta. I remember seeing that as a crayon. All right. That's that. Let's keep it going. Counting or natural numbers. Counting or natural numbers are numbers that you count. Oh, on the wrong thing. Y'all, I apologize for the handwriting, but the lesson is amazing. Isn't this lesson amazing? It's an amazing lesson. Gosh, it's amazing. So counting numbers, we learn to count. We don't say 0, 1, 2. We say 1, 2, 3, 4, blah, blah, blah. Counting numbers. So you count. Counting on natural numbers. Numbers that you count. What don't you see? You don't see 0. So no 0. You see no fractions or decimals. Look at this beautiful handwriting. Oh my gosh. And you don't see what? Negatives. I don't know what kind of N is that, but you get the point. You don't see any negatives. You know why? Because counting, we learn to count by 1, 2, 3, 4. We don't say -5, -4, negative. No, you learn to count. This is 1, 2, 3, 4. No negatives, no fractions or decimals, and then no 0. So quick review, because you need to know this by heart, because this is review. If it's not review for you, then you need to learn this by heart. So rational numbers can be written as a fraction or terminating or repeating decimal. Integers are whole numbers and the opposite. So we know the whole numbers start with 0, 1, 2, 3. The opposite of 1 is -1. So the opposite will be a negative number. So we don't see decimals. We don't see fractions. Whole numbers are what they sound like. They're whole. I have a whole lot of nothing. That's how you can remember that 0 is in whole numbers. It's a number in whole number. All right, and then we don't see any negatives or the decimals, and then counting numbers, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we don't see 0 because we start with 1 when we count. All right, all of these are rational numbers because all these numbers terminate, or none of these repeat. All these numbers terminate, they stop. All right, let's get to irrational numbers. Irrational numbers are numbers. If you can write rational numbers as fractions, what do you think about irrational numbers? I knew you were intelligent. You can't be written as a fraction. Can be written as a fraction. These decimals, they are also ugly looking decimals. Decimals that never repeat, this handwriting, or terminate. Okay, so if rational numbers right here, if they, come on, mouse, get your life together. Where you at? Where you at? Click. There you go. If rational numbers terminate, then irrational numbers don't. If rational numbers repeat, then irrational numbers don't repeat. If rational numbers can be written as a fraction, then irrational numbers can't be written as fractions. All right, people, let's go. Let's move on. So let's give some examples. So the most common irrational number, I know you know this, it has its own day. The most common irrational number would be pi. I ain't say the most common, I say the most popular. I'll say the most popular. Most popular, pi is the most popular. Pi is 3, where's my calculator at? It's a shame I only learned 3.14. I think there's a 127 or something like that. So let me hit pi on my calculator. Where are you at, pi? Come on here. Where are you? Y'all, I can't even find pi on my calculator. Where are you at? Okay, there you go. I had to yell at it. So pi is 3.141592654, blah, 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 blah. It has no repeating patterns, and it goes on forever. Irrational, the most common irrational number. All right? And then non-perfect squares. And I know we haven't talked about this because I expect y'all to learn this from last year. But a perfect square, these are the perfect squares. Don't write this down. You can put it on the back. Put this on the back if you want to. I'm going to erase this. Do not write this right here. Put this on the back. You know, somebody's going to show up with it written right here. And we're like, oh my God, I didn't know. How you not missed that? I said it like 5 times. Don't put this here. Put it on the back. All right, so perfect squares are numbers that can be squared and the result of those. 1 squared is 1. That's a perfect square. Perfect square. Think about a perfect square. 2 squared is 4. I mean, this is on your perfect squares and cubes test. 3 squared is 9. So when I take the square root says what number squared gives me that number. Well, the square root of 1 is 1 because 1 was squared to give me that. The square root of 4 is 2 because 2 was squared to give me 4. The square root of the square root of 9 is 3 because 3 was squared to give me 9. So if I understand that, then those are perfect square. Non-perfect squares are numbers that there is no number that I can square to give me that number. Let's see one. So the square root of 13 is a non-perfect square because no number squared will give me 13. The closest I can get to 13 is between what 2 numbers? Well, if I square 3, that's 9. And then if I square 4, that's 16. Well, those are the only perfect squares. This is a non-perfect square, which means that it's irrational. This number goes on and on and on forever. It gets really close to 13, but there is no number you can square to get 13. Another non-perfect square is 85. What's the closest one to it? Well, you know, if I square 8, I get 64. Square 9, get 81. And square 10, I get 100. So I got 81 and 100. But there is no number that I could square to give me 85. So it's a non-perfect square. It's irrational. It keeps going and going and going without a pattern. Okay? So that is what you need to know for your notes and for your work. I did this video in under 15 minutes. I think I'm a beast. And so because I know I'm a beast, I don't think I'm a beast. My middle name is Beast. You know, I'm going to sign out like a beast. This has been Mr. O'Neal. There is no reason why anyone should not get 100 on their worksheet, which I'm going to go to now. So I guess I'm going to pause the video and then give you directions for the worksheet. So I'll be right back. I'm pausing the video. I think I'm pausing the video. Hey, I'm back, and I just realized that I won't be able to color this without, let me see if I can, oh, look at here. Y'all gonna watch me work this magic. I need to put this on another paper. Copy this over here. Come on, man. These kids are waiting on me. Scroll this up. Hopefully this works out right. Look at there. Beast mode, son. Get on my level. Get on my level. All right, all I did was copy. Anyway, simplify fractions and square roots. For example, are the directions right here? Yeah, directions. Color all natural or counting numbers red. All right. Oh, sorry. This is very important because y'all forget this. It says simplify fractions and square roots. For example, 6 over 2 is 3 and the square root of 25 is 5. So before you begin, I will go through and simplify all of the perfect squares and all of the fractions that can be simplified. So I'm going to give you a hint. I'm going to go through the first 2 rows. Yep. First 2 rows. So 2/3 can't be simplified. Square root of 5 is a non-perfect square. That's irrational. Can't simplify that. But 9 over 3 simplifies to 3. All right? So you can put it, you can put 3. Square root of 8, it's a non-perfect square. There's no number squared that'll give me 8. If I go to the next row, square root of 11, no number squared gives me 11, but 10 over 5 reduces to 2. So some of y'all might want to put 2 there. Whatever, I don't know. Pick the color that it goes with. What color are these numbers? Well, we know that these numbers are rational, but it says color all natural or counting numbers red. So they're making a progression down. So 2 is a counting number because we go 1, 2. So we'll color this red. I'm on red. So I know that this is red. And I know that this is red. And square root of 16 is 4. That's 4. So that means this is red. Square root of 1 over 4. Well, the square root of 1 is 1. The square root of 4 is 2. So that's 1/2. That's not a counting number. That is a rational number because it is a fraction. So the way you do this, and I'm telling y'all this now because some of y'all come in with some crazy colors. I'll be just like, what are y'all talking about? You didn't learn your numbers. So all natural accounting numbers are red. Okay, because I'm here, I hit you up with the red. So anything that I can count, any number I can count is red. So 14 is red. What else is red? 9. I'm doing the first 2 rows. 9, 10. Your colors are better be better than this. I'm telling you now. 9 and 10 are red. You are negative. You can't count you. You're a decimal, non-perfect. Yep. Got all the counting numbers. The next color, it says color any remaining whole numbers purple. So whole numbers are including 0, 1, 2, 3. So the only number I can look for is 0 because everything is a counting number except for 0. So in my first 2 rows, there is no 0. So I have no purple. I don't care, purple or brown. Color any remaining integers green. Integers include numbers. Let's use the highlighter. Come on, Mr. O'Neill. You should have been using the highlighter the whole time. These scribbles. All right, so any remaining integers green. So integers are whole numbers and their opposite. So -1, you are an integer. Get it. Come on here. What are the integers? Any more? -15, you are an integer. Get out of here. Okay. All right. And I know integers can't be decimals or fractions. So 2/3 can't be an integer. This is a decimal. You're square root of 5. I'm not going to go through all of that. Okay. Color any rational numbers yellow. Come on, yellow. Let's go. Yellow. So rational numbers can be numbers that can be written as a fraction or repeating decimal. You repeat, you have a bar, you terminate. You clearly don't. Square root of 8 is irrational because it's non-perfect square. You terminate. Square root of 14 is non-perfect square, so you're irrational. And then irrational numbers are blue. Come on, blue. Let's go. Blue, irrational. You're not a perfect square. 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 And so, oops, I forgot about 1/2. 1/2 is rational because you are a fraction. You are 1/2. And if I was nice with it, I'll go in here and just turn these. Oh, get on my level. Look at these coloring skills. Y'all wish y'all were as great as me. Hopefully I didn't make any mistakes in the first 2 rows. That's what you're doing. You need color pencils. You need the right colors. If you don't have color pencils, I left some out, and I left a note for who's covering me to take your shoe or your phone. All right, I am done. It's been another great, wonderful day. This is Mr. O'Neill, another Beast Mode production, because that's what I do with my life, and I'm out.